We're going to talk about the second type of mole calculation. And you're going to notice that I have Avogadro's number written at the top here. And notice that the number, we just keep it to 6.022 times 10 to the 23. This could be cookies per mole, atoms per mole, molecules per mole, whatever number of substance you have where you're counting particles, we put that per mole of a substance. Notice that we have a second mole triangle here, and what that would look like in terms of variables, we let the letter N mean mole, and then on the top, we would have number of particles or number of molecules or number of atoms. That goes on the top. And on the bottom, we have Avogadro's number, which is written as capital N with a lower subscript capital A. Now, this formula here, not a big fan of because there's so many N's involved, but hopefully you can learn to keep that straight in your head by learning what each of those symbols represents. So in this particular question, they're asking you for how many molecules of magnesium chloride are in a 0.789 mole sample. So in this scenario, they're asking you for number of molecules. So that is our unknown. They give us moles, so that is our letter N. So our letter N represents 0.789 moles. And we always will know Avogadro's number. We always know that. That's just a number that we have to memorize. Okay? So if I had to solve for number of molecules, that's this symbol here, we would have to rearrange this to isolate number of molecules as a single variable on the top, and we leave it as a numerator. So if I was to bring Avogadro's number to the other side of the equal sign, instead of being divided, it would be multiplied. You can use this mole triangle if you were trying to solve for number of particles. This is a variable that you are trying to find, so you would cover that up, and then you would notice that these two are side by side. So in the mole triangle, the variables that are side by side, you always multiply, and if they're on one on top of the other, you would divide. So in this case, when I rearrange, number of molecules equals moles times Avogadro's number. And now I can substitute my values in. 0.789 moles times 6.022 times 10 to the 23. Now, because this is a molecule, I write down molecules per mole. And what I notice in this scenario is that my moles will cancel out because I have one unit that is in the numerator, one in the denominator, and then I go ahead and I put this into my calculator. Now, in putting this in my calculator, to enter in Avogadro's number, which I'll put first, 6.022, I use my EXP button, and that already gives me the times 10, so I don't put times 10, that EXP button does that for me, 23, so there it is there. I will multiply that by 0.789, and I get this big number, 4.751358. Notice that space means times 10 to the 23. How many significant digits am I going to report to? Well, I take a look at my original question, and I notice that there are 3 significant digits. Remember that any zero that is preceding a decimal is just a placeholder. So we have 3 significant digits. So my answer will be 4.75 times, now remember that's what that space means, 10 to the 23. If you just wrote 4.75 and you forgot the times 10 to the 23, that doesn't make sense because this is roughly 5 molecules, but this value is really 4.75 trillion billion molecules. So it's really important that you keep that exponent there, and we really should have our unit of molecules. So when you have a 0.789 mole sample of magnesium chloride, this is how many molecules would be in that sample. Down below, it's asking you to count how many atoms of magnesium and how many atoms of chlorine are in the above sample. Well, when I take a look at one single molecule of magnesium chloride and I look at the subscripts, I would say that you have 1 magnesium and you have 2 chlorine. Now, what if I was to put a 20 in front? You have 20 molecules of magnesium chloride. How many atoms of magnesium would you have? Well, in this scenario, you would just take your coefficient and you would say, oh, I have 20 magnesium atoms and I have 40 chlorine atoms. What if I was to put a 100 in front? Well, you would have 100 magnesium and you would have 200 chlorine. What if I was to put 4.75 times 10 to the 23? So 4.75 trillion billion molecules of magnesium chloride. How many magnesium atoms would you have? So in this case, what you would do is you would do exactly what you did before when you were working with numbers that didn't have any exponents. You would have 4.75 times 10 to the 23 magnesium atoms, and you would have 2 times that value. So you would have 9.50 approximately times 10 to the 23 chlorine atoms. So that's how we figure out how many atoms we have in the above sample. In this question, I'm going to take you through a multi-step mole calculation that involves both mole calculations. Up at the top, I'm just going to write down what the first formula is, where it's moles equals mass over molar mass. And the second calculation to calculate moles equals number of molecules or formula units or number of atoms all over Avogadro's number. In this first question here, it asks you, what is the mass of 5.67 times 10 to the 24 molecules of cobalt-2 chloride? Now, when I'm doing calculations, I always like to put down what is given and what is required. So in this case, number of molecules is the symbol NO. And that way it helps me to solve my equations a little bit better. Now there's only one formula out of the two that has mass in it. So I know that I'm going to get my target equation from mole calculation number 1. So my target equation in this case, when I go to rearrange this formula, mass equals moles times molar mass. Now in this case, I don't have moles. I cannot just substitute molecules for moles. They are not the same thing. I know that I can get molar mass of cobalt-2 chloride by going to the periodic table. Now, cobalt-2 chloride is CoCl2. And I know from the periodic table, when I go and take a look at the average atomic weight for cobalt, it is 58.933 grams per mole. And chlorine is 35.453 grams per mole. Because I have 2 chlorines, I would have to double that. So what I'm going to do on my calculator is just do the molar mass all in one step. So how do I do that? I just enter 58.933 times, I use my close bracket, 35.453 times 2, because there's 2 chlorines. And oops, that didn't give me the right answer. 58.933 plus, close bracket, 35.453 times 2. And that's much better. So the molar mass of cobalt-2 chloride is 129.839. So I'm just going to record that over here. And I don't want to drop any digits at this point, because if you start rounding too early, then you are going to get an inaccurate answer at the end. So I have molar mass, which is perfect. I do not have moles. So what I need to do is I have to go and look at the second mole equation, and I'm going to substitute this calculation in for moles because I'm given number of molecules. So mass will equal number of molecules all over Avogadro's number times molar mass. Now I have an equation where I have only one variable that I'm solving for, and I know the rest. So when I substitute in number of molecules, 5.67 times 10 to the 24, Avogadro's number is 6.022 times 10 to the 23. I'm just going to put my units in so you can see what ends up canceling out. We're going to multiply that by the molar mass, which is 129.839 grams per mole. Mass is the variable that I'm solving for. I do like to see you include the variable to the left of the equal sign. When we go and take a look at what units cancel out, we know that a numerator and a denominator, molecules cancel out, moles cancel out, and you're left with grams. And so you know that you're solving for the right variable when the units match. How do I enter this in my calculator? Well, for me, I always find that if I divide anything that has an exponent, it's always best to use your bracket keys. So when I go to do this, I'm going to enter this value first. And in doing that, I just want to show you, this is the calculator that I'm going to be using for now. I enter 5.67 EXP. It already does the times 10 for you, 24. So there's that value. I'm going to divide that by, use my bracket key, 6.022 EXP 23, close bracket key. I push equals. That gives me this value in here. Now I'm going to multiply it by 129.839, and I get an answer of 1,222.496064. Now, how many digits am I going to report to? So for right now, I'm going to include a few of them here, and then I'll show you how best to figure out how many digits you are going to keep your answer to. When we go back and take a look at the original question, we have 3 significant digits. So your final answer has to be rounded to 3 significant digits. The way to get around that is to put your final answer into scientific notation. So I move my decimal place in between my first 2 digits, 1, 2, 3. Because I moved my decimal place 3 spots to the left, we would report this as 1.22. There's my 3 significant digits, times 10 to the 3 grams.